This is Introduction to Trigonometry, the law of sines and cosines. The law of sines and cosines. In your online textbook, this information is also covered in pages 421 to 425. Please note the location that you are watching this video as well as the date and time. The date and time. We're going to do a quick review using brain and hand techniques. I would like you to finger track and read this problem, highlight, underline, draw, label, list, have, need, do, and solve. Pause the video at this point and attempt to solve this problem on your own, then come back and check your work. Okay, welcome back. It says here, we have a radio tower. A radio tower is anchored on both sides by guide wires. The wires are anchored 30 feet from the base of the tower to the top of the tower. The angle of elevation from the guide wire to the top is 42 degrees. How tall is the radio tower? So we highlight and underline. Now we're going to draw, label, and list. Our players are basically here. We have a radio tower of some sort. So it's sending out radio waves. And we have guide wires that anchor the top of the tower. Top of the tower to the ground. And there's guide wires on both sides. So we have a radio tower, guide wires. The guide wires are 30 feet from the base. So here's the base, 30 feet. So this right here is 30 feet. The angle of elevation, and again that's at a horizontal going up, is 42 degrees. How tall is the radio tower? So how tall is the radio tower? That is going to be our x. So have, need, do. We have, in this case, here is our hypo. Here is our adjacent. This would be the opposite. What is it that we have? We have the adjacent side, and we need the opposite side. So we have an OA combination with OA combination, and what goes with OA is tangent. So we write out tangent of theta equals opposite over adjacent. In this case, it's tangent of 42 degrees equals our opposite, which is x, over our adjacent, which is 30. Put parentheses around this, so when you cross multiply, we get 1 times x, which is just x, equals 30 times the tangent of 42 degrees. So in your calculator, at this point, we can go 42 tan, which is 0.9004 times 30, and we get 27.01 feet. So the height is approximately, of the radio tower, 27 feet, given this distance. Now notice, this is a right triangle. Everything we have studied so far, we're going to preview something called law of sines and law of cosines. And everything we have studied so far is related strictly to right triangles. Let me just recap for you. If you have a right triangle with an altitude, we use geometric mean. If you have a right triangle with 2 sides, you need a third side. That's Pythagorean theorem. If you have a right triangle, either a 30, 60, 90 or 45, 45, 90, you can use the 30, 60, 90 and 45, 45, 90 tables. If you have a right triangle with meeting a side and any kind of angle, you use SOHCAHTOA. If you have a right triangle with two sides and you need an angle, you can use inverse sine, cosine, and tangent. But if you look very carefully, all of these depend on starting with a right triangle. Well, not everything in life is a right triangle. The techniques you've been using have only been for right triangles. But what if it is not a right triangle? Triangles that are not right, basically anything else but a right triangle, those are called oblique. Oblique means a non-right triangle. What do you do with oblique triangles? Like obtuse or acute triangles. What do you do with those? There's two basic scenarios when you're looking at oblique triangles. The two scenarios are this. One is that you have a given situation where you have more angles than a side, and another one in which you have more sides than you have angles. And there's two different situations, and therefore there's two different equations. When you're working with more angles than sides, you're going to use something called law of sines. Law of sines. And law of sines is a giant proportion. And then your other scenario is if you have more sides than angles, you use law of cosines. Law of cosines. Let's take a close look at both of these. Law of sines says I can do this. You have a triangle here, and you have three sides. You have side A, and then you have angle A right here. And then you have side B, and then you have angle B. And side C, and then you have angle C. The sides and the angles are opposite of each other. That's very important. You have that proper orientation. That's why those arrows are there. And you can set up your proportions one of two ways. You can do the sine of angle A over side A equals sine of angle B over side B equals sine of C over C. Or you can flip it and say the side A over sine of A, etc. You can use either orientation, whatever gets you the best situation. Now notice, normally you don't work with two equal signs. So what you do is you find the combination that works for you, and you're only going to use a portion of the equation at a time. Maybe that portion, or this portion, or you can even connect A to C, depending on the circumstance. Let me show you how this works. It says we're going to solve for all missing sides and angles. All missing sides and angles. Well, let's look at the connection I have already. I have a complete C set. I have side C and I have angle C. So I know whatever I do, I'm going to use side C over sine of angle C. Why? Because I have a complete set. Now I also have an A angle, but I'm missing the A side. So that's the first thing I'm going to try to find here. So I'm going to look for the A side, and I have sine of angle A. So that's my first setup. Now we plug stuff in. C I have, circle C, circle, put it there, over sine of C, which is 42 degrees, Put parentheses around that. It is very important you treat that as a single unit. It is not 42 that you're working with. It is sine of 42. Equals our unknown A side over the sine of 54 degrees. Put parentheses around that. Again, it's not 54, it's sine of 54. You cross multiply. And what we have here is we have A times the sine 42 degrees equals 9 times the sine of 54 degrees. To solve for A here, we're going to divide both sides by sine of 42 degrees. Again, keep it as a unit. Cross out. So now at this point we get out our calculator. And we have here, we're going to have A equals 9. And we have to find the sine of 54. So we do 54 sine. That's 0.8090. And then the sine of 42, 0.6691. So to find side A, we're going to do 9 times this and then divide by that. So 9 times 0.8090 divided by 0.6691 equals, we get 10.9. So A, side A equals approximately 10.9. Now we can just do a quick, kind of a logical check. Notice 54 is the larger of the angle, therefore 10.9 is the larger of the sides. 42 is the smaller angle, therefore it is also smaller of the sides. That's a quick way to check. Now we're also missing both angle B and side B. But if you look really closely, angle B is really easy. We just add these two, take it away from 180. So I'm going to go 180, and I'm going to minus 54, and then minus 42, and I get 84. Now I'm going to do, obviously I want B here, so I'm going to show you that you can flip this. It really doesn't matter which way you go. Sine of B over side B equals, I'm going to start with my original. I'm going to go ahead and use C equals the sine of angle C over side C. Plug these in. So it's going to be the sine of 84 degrees over an unknown B length equals the sine of 42 degrees over 9. Putting parentheses around these, we're going to cross multiply. And we get B times sine 42 degrees equals 9 times sine 84. We're going to divide both sides by sine of 42. Make sure you keep parentheses around that. So that B equals 9 times the sine of 84 divided by the sine of 42. We're going to figure out what both those are. 84 sine is 0.9945. Just going to do this, cross that out, 9945, and then the sine of 42, 0.6691. Cross that out, 0.6691. So to solve for b, we're going to do 9 times 0.9945, and then we're going to divide by 0.6691, and we get 13.4. So b equals 13.4. Now, here's just a quick logic check. 84 is the largest angle. That means side B must be the longest side, which it is, out of 9, 10.9, and 13.4. So now we have solved for all the sides and all the angles. What I'd like you to do is follow the same process. That's the one we just did. That's called the law of sines. Now, law of cosines says this. Law of cosines. We use law of cosines when there's more sides than angles. More sides than angles. And the law of cosines is a little bit more complicated. It's not hard to memorize if you just look at a very simple pattern. If I want to work with side A, I take a squared equals b squared plus c squared minus brackets 2 times b times c times the cosine of angle A. A couple patterns. Here's side A connects with the angle right here. And you should also notice that the two sides that you square here are the two sides that get multiplied. Basically, it's the same equation all 3 times, just one focuses on A, the other side B, and side C. You should memorize these. So b squared equals a squared plus c squared minus 2 times a times c times cosine b. And then c squared equals b squared plus a squared minus 2 times b times a times cosine c. So here's a scenario where we have more sides than angles. So this is where we're going to use law of cosines. Law of cosines. Let's label our sides. We have here angle B. That makes this side B. And here is side A, which goes with angle A, which we don't have. And then we have side C, which goes with angle C, which we also don't have. We're going to solve for everything that we can. We're going to start by working with what we do have. Since we have angle B, we're going to start by solving for side B first. So we're going to start with the equation that starts with B. So it's going to be b squared equals a squared plus c squared minus 2 times a times c times the cosine of 28 degrees. Oops, it's cosine theta. Let's do the basic equation first. Actually, it's cosine b. There's your basic equation. Now we're going to plug stuff in. B we do not have, so it's simply b squared equals, we do have A. A is 18. We're going to square it. Plus, we do have C. We're going to square it. Minus 2 times A again, times C again, times the cosine of B, which is 28 degrees. Now, do not be intimidated by this. Here's a trick. You should basically work, in this case, from right to left. So I'm going to get those values on the right first. So we're going to work right to left here. So we're going to start with cosine 28. Watch the calculator very carefully. So first we do 28 cosine. There's our decimal. We times by 15. We times by 18. And then we times by 2. We're going to get 476. We'll take it to the tens place. 476.8. 476.8. So this whole expression here is 476.8. We're going to bring down the b squared here. B squared equals, now let's do 18 squared while we're at it. So 18 squared is 324. Plus 15 squared, you should already know, is 225. And then we have this minus symbol here. Okay, now we can work this way. We're going to go 324 plus 225, and we're going to minus 476.8. We get 72.2. So now it's looking manageable. B squared equals 72.2. The last step, of course, is to square root both sides. (72.2) square root, I get 8.5. So B equals approximately 8.5. Okay, now we have B. Now we have all three sides. The problem is we need some angles here. And we have neither angle A or C. But we are going to use this B combination to solve. So I'm going to work with angle A first. So I'm going to use the A equation. The A equation looks like this. Let me go ahead and... Okay, the A equation looks like this. A squared equals B squared plus C squared minus parentheses 2 times B times C times the cosine of angle A. Now in this case, the unknown is this right here. So be very careful that you have to keep that cosine and A together at all times. Let me show you this step by step. Let's plug in our numbers. We have here 18 is A, so we have 18 squared on this side, equals, we have our B now, so it's 8.5 squared, plus our C, which is 15, minus 2 times B, which is 8.5, times C, which is 15, times the cosine of A, which I'm going to leave as a separate entity, and I'd like you to put parentheses around that, please. Okay, let's do our number crunching first. Let's see, we already did 18 times 18, so 18 times 18 over here is 324, 8.5 squared, is 72.25, plus 225, minus, and then we're going to do here 2 times 8.5 times 15, that's going to be 255, times the cosine of angle A. These can add. Be very careful. Do not minus 255 because 255 is attached right here, it's attached by multiplication to cosine of A. So what we're going to do now is we're going to add the 72.25 plus 225, and that's 297.25. So our next line looks like this. 324 equals 297.25 minus 255 times cosine angle A. Okay, now what we need to do is we're going to subtract 297.25 324 minus 297.25 equals 26.75. 26.75, and that's going to equal negative 255, because there was a minus sign there, times cosine of angle A. We're going to divide both sides by negative 255. Why are we dividing? Because that's the opposite of timesing. These cancel. That's 0.01049, and it's negative. Equals the cosine of angle A. So what we're going to use here is called inverse cosine. At this point, we're going to do cosine negative 1 of negative 1049. That's going to give us angle, actually that should have been C. Oh, no, is it A? No, it's A. Yeah. It's going to give us angle A. Okay, so here we have negative 0.1049, and now we do inverse cosine, and we get 96 degrees equals angle A. So we come up here, we have 96, which makes sense because it is the longer side goes with the largest. Now to find that angle C, we don't have to go through all that because we already have two angles. Now we simply do 96 plus 28, take that away from 180, and we get 56 degrees. And that is how you solve using law of cosines.